Hey everyone, welcome to the fascinating world of calculus. Don't worry, it's not as daunting as it sounds. In fact, it's pretty cool once you get the hang of it. Calculus is like a powerful tool that helps us understand how things change. From the smallest particles to the vast expanse of the universe, calculus is everywhere. Imagine trying to measure the speed of a cheetah at its fastest sprint. It's constantly changing, right? Calculus gives us the tools to measure those instantaneous changes. Or think about calculating the area of an irregular shape. Calculus can help us with that too. Calculus is divided into two main branches, differential calculus and integral calculus. Differential calculus deals with rates of change, while integral calculus deals with accumulation. Together, they provide a powerful framework for understanding and solving a wide range of problems. So, are you ready to embark on this exciting journey? Buckle up and let's explore the wonders of calculus together. Let's start our calculus adventure with the concept of limits. Imagine you're walking towards a door. You're getting closer and closer, but you never actually reach it, right? That's kind of like a limit. In calculus, a limit tells us what happens to a function as its input gets closer and closer to a specific value without actually reaching it. It's like peeking into the function's behavior at a particular point. For example, let's say we have a function f of x equals 2x. What happens to f of x as x gets closer and closer to 2? We can see that as x approaches 2, f of x approaches 4. We can write this mathematically as the limit as x approaches 2 of f of x equals 4. Limits are fundamental to calculus because they form the basis for understanding derivatives and integrals. They help us analyze the behavior of functions at specific points and provide a framework for understanding continuous change. So, remember, limits are all about approaching a value without actually reaching it. They're like sneaking up on a function to see what it's doing. Now, let's dive into the exciting world of derivatives. Derivatives are like detectives of change. They tell us how much a function is changing at any given point. Imagine you're driving a car. Your speedometer tells you your instantaneous speed, right? That's exactly what a derivative does for a function. It gives us the instantaneous rate of change of the function at a specific point. For example, let's say you're on a roller coaster. The derivative of the roller coaster's height function would tell you how steep the ride is at any given moment. A steeper slope means a greater rate of change in height, which translates to a more thrilling ride. Mathematically, the derivative of a function f of x is denoted as f prime of x. We can calculate the derivative using a set of rules and formulas. Derivatives have numerous applications in various fields. They're used in physics to calculate velocity and acceleration, in economics to analyze market trends, and even in medicine to model the spread of diseases. Now that we've explored derivatives, let's move on to integrals. While derivatives tell us about rates of change, integrals help us calculate the total accumulation of a quantity over an interval. Imagine you're filling a bathtub with water. The integral of the water flow rate over time would tell you the total amount of water in the tub at any given time. Cool, right? In calculus, an integral is represented by the symbol. It's like a stretched out S and stands for summation. Integrals are closely related to derivatives. In fact, they're like two sides of the same coin. The fundamental theorem of calculus establishes this beautiful relationship. Integrals have numerous applications in various fields. They're used in physics to calculate work and energy, in statistics to determine probabilities, and even in computer graphics to create realistic images. So, remember, integrals are all about accumulation. They help us calculate the total amount of something over a given interval,